In 79 AD, a mountain that had been silent for centuries gave the residents of Pompeii roughly 18 minutes of warning before it erased them from history. And right now, scientists monitoring Vesuvius are watching readings they haven't seen in decades. 18 minutes. That's not a typo. For many of the estimated 2,000 people whose remains have been excavated at Pompeii alone, with estimates of total regional casualties ranging into the tens of thousands. That was the entire window between a normal Tuesday morning and obliteration. Some of them were eating. Some were conducting business. A child in the Villa of the Mysteries was found curled near a doorway, as though she'd simply decided to wait it out. What makes this relevant today, urgently, uncomfortably relevant, is that the volcano responsible for all of that is not dormant. It has never been dormant. Vesuvius last erupted in 1944, living memory for some people still alive today, and beneath its iconic silhouette, a magma system that scientists describe as increasingly pressurized is being watched around the clock by instruments that didn't exist the last time it truly awakened. The question researchers at Italy's National Institute of Geophysics and Volcanology are wrestling with isn't whether Vesuvius could erupt again. It's what happens to the nearly 3 million people now living in the zones that ancient Romans, with no warning systems, no volcanology, no evacuation infrastructure, simply had no chance of surviving. That's what this is about. Not panic, not prophecy. Awareness. Because the more you understand what's actually happening beneath southern Italy right now, the more clearly you can see why this particular volcano demands our attention. Mount Vesuvius doesn't just sit near Naples. It sits inside one of the most densely populated volcanic hazard zones anywhere on the planet, and that distinction matters enormously when you start running the numbers. The city of Naples itself, home to roughly 1 million people, sits approximately 9 kilometers from Vesuvius's summit. 9 kilometers. For context, that's the distance you might casually drive to a grocery store. The broader metropolitan area, the Campania region, pushes the at-risk population well past 3 million when you account for the towns and municipalities that fan outward across the bay and up into the surrounding hills. This isn't a volcano in a remote mountain range. This isn't a hazard confined to unpopulated wilderness. Vesuvius is essentially suburban. The towns of Ercolano, Torre del Greco, Portici, and Herculaneum, yes, the same Herculaneum that was buried in 79 AD, still exist today, rebuilt and repopulated, sitting within what Italian civil protection authorities designate as the red zone, the area considered most at risk from pyroclastic flows in the event of a major eruption. Approximately 800,000 people live in that red zone right now. And then there's the economic and cultural dimension that makes this even more staggering. The Naples metropolitan area generates an enormous share of southern Italy's economic output. The region contains some of the most significant archaeological and historical sites in the world. Pompeii itself draws millions of tourists annually, operating essentially in the shadow of the volcano that created it. The port of Naples is one of the Mediterranean's busiest. The transportation infrastructure threading through Campania would be catastrophically disrupted by even a moderate eruptive event, and that disruption wouldn't stop at Italy's borders. What makes the current situation feel different from simply acknowledging that an active volcano exists near a major city, because we've always known that, is the compound threat. Vesuvius doesn't operate in isolation. It shares a deeper geological heritage with the Campi Flegrei caldera system just to the west of Naples, and Campi Flegrei has been in a period of intensifying unrest that has genuinely alarmed the scientific community. In 2023, Italian authorities raised the alert level at Campi Flegrei to yellow, and the two systems, while distinct, are part of the same broader volcanic province. When one shows signs of stress, researchers pay closer attention to the other. To understand what's actually happening beneath Vesuvius right now, you have to understand the plumbing system that feeds it. And it's more interconnected, more pressurized, and more volatile than most people realize. Vesuvius is classified as a stratovolcano, sometimes called a composite volcano, which means it's built up over thousands of years from alternating layers of hardened lava flows, compacted ash, and volcanic rock. That layered structure is part of what makes it so dangerous. Stratovolcanoes tend to erupt explosively because the silica-rich magma they produce is thick and viscous, trapping gases that build pressure until the system reaches a breaking point. Think of it like this. If you shake a carbonated drink and slowly unscrew the cap, the gas has time to escape gradually. That's what a less viscous magma system looks like. Slow outgassing, gentler eruptions. But if you shake that same bottle and then suddenly remove the cap entirely, the pressurized gas and liquid explode outward at once. Vesuvius, geologically speaking, is closer to the second scenario. Its magma is the kind that holds gas under pressure, and when the pressure releases, it tends to do so catastrophically. The magma chamber, the reservoir of molten and partially molten rock that feeds the volcano, sits roughly 8 to 10 kilometers beneath the surface, according to research published by teams at the Istituto Nazionale di Geofisica e Vulcanologia. What the recent seismic tomography studies have revealed is a TAO system that appears to be in a state of recharge. Magma is migrating upward. The chamber isn't a static fixed reservoir. It's dynamic, being fed from deeper in the mantle, and the current data suggests that process is ongoing. Now here's where it gets complicated, because the word full, as it appears in descriptions of the current magma chamber status, requires careful translation. Volcanologists don't use that term lightly, and they don't mean it the way a gas tank is full. What they mean is that the chamber appears to have reached a level of magmatic volume and pressure that historically has preceded eruptive episodes. It's not a digital gauge that tips over into red. It's a pattern, a constellation of measurements that, when viewed together, indicate a system under increasing stress. Ground deformation data shows measurable uplift in the surrounding region. Seismic monitoring networks have recorded clusters of small earthquakes, what volcanologists call seismic swarms, that indicate fluid movement within the volcanic system. Geochemical monitoring of fumaroles, the gas vents on the volcano's flanks, shows changes in sulfur dioxide output and carbon dioxide ratios that are consistent with magma sitting closer to the surface than it was a decade ago. Each of those signals, individually, could have an alternative explanation. Taken together, the ground uplift, the seismic swarms, the geochemical shifts, they form a picture that has put Vesuvius on the serious monitoring radar of institutions far beyond Italy. The USGS Volcano Hazards Program maintains global awareness of supervolcano and major volcanic systems precisely because an event of sufficient magnitude doesn't respect national borders. What scientists can't tell you, and this is critical to understand, is exactly when any of this might translate into eruptive activity. Volcanology has advanced enormously in the past 50 years, but predicting the precise timing of a volcanic eruption remains one of the most challenging problems in Earth science. What monitoring systems can do is detect escalating signals, distinguish between background noise and meaningful anomaly, and, crucially, provide enough lead time for evacuation if the signals intensify toward critical thresholds. The question of whether 3 million people can actually be evacuated in time is, as we'll get to shortly, a very different and much more sobering question. Pompeii is the name everyone knows, but the 79 AD eruption was not the worst thing Vesuvius has ever done. And understanding that history reframes the entire risk conversation in ways that are deeply uncomfortable. The 79 AD event, which buried Pompeii, Herculaneum, Stabii, and Oplontis under meters of ash and pyroclastic material, is estimated to have had a volcanic explosivity index rating of approximately 5, what volcanologists call a Plinian eruption, named after Pliny the Younger, whose extraordinary eyewitness letters remain the most detailed first-person account of the disaster. Pliny was 17 years old when Vesuvius erupted. He was staying with his uncle, Pliny the Elder, a naval commander and naturalist who would ultimately die attempting to rescue survivors by boat. In his letters to the historian Tacitus, written years later, Pliny the Younger described a cloud rising from the mountain in the form of a pine tree. The now iconic mushroom-shaped eruption column that we recognize immediately from his description. He wrote about darkness so complete that it was blacker than any ordinary night, about ash falling like snow, about the ground shaking so violently that the buildings around him seemed to sway and shift. His uncle's ships, approaching the shore to rescue survivors, encountered pumice and debris so thick they could barely navigate. That was a VEI 5. What researchers have now documented through geological analysis is that Vesuvius is capable of significantly larger events. The Avellino eruption, which occurred approximately 3,900 years ago, was a VEI 6, 10 times more energetic than the event that destroyed Pompeii. Archaeological and geological evidence suggests it displaced the Bronze Age populations of the region entirely, covering an area of hundreds of square kilometers in deposits deep enough to bury entire settlements. Recent excavations near Nola have uncovered preserved Bronze Age villages beneath meters of volcanic material, ghost towns from a catastrophe that predates Rome by more than a millennium. The Campanian Ignimbrite event, occurring roughly 39,000 years ago, was potentially a VEI 7, 100 times more powerful than 79 AD, and possibly one of the factors that contributed to a population bottleneck in early European human populations. That event deposited volcanic material across an area extending into what is now Eastern Europe. Let that sequence settle for a moment. A VEI 5 destroyed one of the most sophisticated urban centers of the ancient world. A VEI 6 depopulated an entire region 3,000 years before Christ. A VEI 7 may have left a mark on human genetic history. The current Vesuvius system is considered capable of events across this range, and while the most likely near-term scenario, if an eruption were to occur, would probably resemble the smaller end of the spectrum. Probably is not a word that provides much comfort when 3 million people are living in the potential impact zone. The human texture of these historical events is worth dwelling on, because it's easy to process geological data as abstraction. In 2018, archaeologists at Pompeii excavated the remains of 2 men in a newly opened area of the site, one wealthy, one likely a slave, found side by side in what appeared to be a room they'd sheltered in together as pyroclastic surge overtook the city. The surge, a superheated cloud of gas and volcanic material moving at hurricane speeds, reached temperatures estimated at between 300 and 600 degrees Celsius. It killed essentially instantaneously. The position of the remains suggested they had almost no warning. One of the men had his hands raised near his face, as though instinctively shielding himself from something he'd only just become aware of. 2,000 years later, archaeologists read that gesture in the hardened ash and understood exactly what it meant. Italy's National Institute of Geophysics and Volcanology, the INGV, operates one of the most sophisticated volcano monitoring networks in the world, and what their instruments are currently showing has put researchers on edge in ways that the official alert levels don't fully communicate to the public. Vesuvius is currently at alert level green, the lowest of 4 levels used by Italian civil protection, which means it is being actively monitored, but has not shown the specific escalating pattern that would trigger a formal alert upgrade. That might sound reassuring. It shouldn't make you complacent, because the gap between green and the next level can close faster than evacuation infrastructure can respond. The monitoring network around Vesuvius is genuinely impressive in scope. Seismographic stations placed across the volcano's flanks and surrounding region record thousands of microseismic events annually, most of them imperceptible without instruments. GPS sensors track ground deformation with millimeter-level precision, the kind of accuracy that can detect whether the volcanic edifice is swelling as magma migrates upward. Tilt meters measure changes in the angle of the ground surface. Chemical sensors at fumarole fields on the crater rim and upper flanks continuously sample gas output, watching for the telltale signatures, increasing SO2, shifting CO2 to sulfur ratios that indicate magma is degassing closer to the surface. What the data shows currently is a system that, while not in acute pre-eruptive crisis, is not quiet either. Ground deformation in the broader Campanian volcanic zone has been ongoing. The seismic picture shows what researchers describe as a background level of activity consistent with a volcano in a state of recharge. And critically, the relationship between Vesuvius and the neighboring Campi Flegrei system, which in 2023 experienced its most significant earthquake in 40 years, a magnitude 4.2 event that was felt across Naples, means that monitoring teams are effectively watching two interconnected volcanic systems simultaneously, trying to understand whether unrest in one influences the other. Italy's national emergency plan for a Vesuvius eruption, the Piano Nazionale di Protezione Civile per il Rischio Vesuvio, was updated in 2019. It envisions evacuating approximately 700,000 people from the highest risk red zone within 72 hours of a formal eruption warning. That sounds, on paper, like a manageable window. In practice, the logistics are staggering. The road infrastructure around Naples, already chronically congested under normal conditions, would be competing with emergency vehicle access, ashfall disruption, potential ground shaking, and the human behavioral reality that some percentage of people in any evacuation scenario don't leave when told to. The 1985 eruption of Nevado del Ruiz in Colombia, a significantly smaller event, killed more than 23,000 people, not because warnings weren't issued, but because the warnings weren't heeded, and evacuation didn't happen fast enough. Researchers who study volcanic risk are acutely aware that a plan on paper and a successful evacuation of a modern metropolitan area under volcanic crisis conditions are two very different things. If Vesuvius were to experience a major eruptive episode, and scientists are careful to stress if, not when, the modeling from the University of Naples Federico II and the INGV paints a picture that is almost impossible to process in its scope. Let's walk through what the science suggests could happen, using conditional framing throughout, because none of this is prediction. This is what the physics and geology tell us is possible. In the first hours of a significant eruption, the immediate red zone would face the gravest danger from pyroclastic density currents, those superheated avalanches of gas and rock that move faster than a commercial aircraft at low altitude and leave nothing survivable in their path. Models suggest these flows could potentially reach distances of 15 to 20 kilometers from the summit under certain eruptive conditions, which would place them well into the greater Naples urban area. The ash column, depending on eruption intensity, could potentially reach the stratosphere, the same altitude where commercial aviation operates, grounding flights across a broad swath of European airspace, as happened with far smaller volcanic events like the 2010 Eyjafjallajökull eruption in Iceland. Ashfall across the region could be catastrophic for infrastructure. Even centimeters of volcanic ash, heavier than it looks, corrosive, electrically conductive, can collapse roofs, shut down water treatment systems, disable vehicle engines, contaminate water supplies, and make roads impassable. Models suggest significant ash deposition could extend across hundreds of kilometers, depending on wind patterns, potentially affecting agriculture and transportation across large areas of southern Italy. The secondary effects ripple outward in ways that are harder to model, but potentially devastating in their own right. Naples is a critical node in Mediterranean shipping and supply chains. The disruption to Italian, and by extension European, economic activity from even a weeks-long volcanic crisis would be measured in figures that are difficult to fully quantify. The tourism economy of southern Italy, already stressed, could face years of recovery. And the humanitarian challenge of potentially relocating hundreds of thousands of displaced people who may be returning to houses that no longer exist, in communities buried under meters of ash, would strain Italian national resources and European solidarity simultaneously. What scientists can say is that the scale of impact would be directly proportional to the intensity and duration of any eruptive event, and that both of those variables remain genuinely uncertain. A smaller reawakening, something closer to the 1944 event, might be devastating locally, but manageable regionally. A larger event, comparable to, or exceeding 79 AD, would be a civilizational stress test for modern Italy and Europe in ways we've never actually had to confront in the modern era. Here's what we know, stripped of the drama. Vesuvius is an active stratovolcano sitting atop a magma system that has erupted catastrophically before, that is showing measurable signs of pressurization, and that has approximately 3 million people living within its officially designated risk zones and beyond. The scientific institutions monitoring it, the INGV, the University of Naples Federico II, international partners, are doing extraordinarily careful, rigorous work. They are not in the business of alarm for its own sake. When they describe the current data as warranting serious attention, that language choice is deliberate and meaningful. What we also know is that the historical record of Vesuvius doesn't allow for comfortable dismissal. This volcano has ended civilizations. It has depopulated entire regions. It has left fingerprints in European genetic history. Treating it as a postcard backdrop or a geological curiosity, rather than as the active hazard it demonstrably is, reflects a kind of collective optimism bias that the ash layers beneath our feet don't support. The awareness itself matters. Understanding why Italian authorities have an evacuation plan, why scientists maintain around-the-clock monitoring, why researchers in multiple countries track Vesuvius's data, is part of what makes it possible for populations to respond effectively when signals escalate. The lesson of Pompeii isn't just that a volcano is dangerous. It's that a civilization that has normalized living with a volcano, that has stopped actively reckoning with what it's sitting next to, is a civilization that loses 18 minutes when it needed 18 days. And here's the thing. Vesuvius isn't the only system we need to be watching. Right next to it, Campi Flegrei has been showing the kind of ground deformation and seismic activity that has genuinely alarmed researchers. And in some ways, the science around that system is even more unsettling than what we've covered today. That's going to be a full deep dive in the next video. Because if Vesuvius is the threat you know about, Campi Flegrei might be the one you've never heard of, and probably should have. If this kind of content matters to you, if you believe that understanding these systems is part of what it means to be an informed person in a world where these hazards are real, then subscribing keeps this research coming. Every comment, every share, every person who watches this to the end, and then actually looks up the INGV monitoring data, or reads about the Piano di Protezione Civile, that's the whole point. Not fear, knowledge. Because in the gap between panic and ignorance, there's a space where awareness actually lives. And that's the space this channel is trying to occupy. Stay informed. The mountain is being watched. And now, so are you.